Today we're going to talk about business analysis, and this is business analysis to build software, the type of software that will support your business operations. It is, as we all know, a challenge. There are solutions. The solutions are intriguing, and I would like to talk about those solutions with you. This is a diagram that shows you how this whole thing is organized. This is our big picture. On the left-hand side, you can see the stakeholders or the subject matter experts. Those are the people who know what they need. These people have invented a business model to implement, I should say, their business vision. The business vision, for instance, if we sell pizza at noon, people will buy pizza and eat pizza. This is our business vision. The business model is what we do so that those pizzas do get to the people who order the pizza. Now, in order for the business model to work, you need, most of the time, you need some IT system that is going to take the orders, that is going to tell the cooks what is supposed to be prepared, that is going to organize so that the pizzas are delivered in time. Well, the IT system, if it is properly built, will be able to support the operations of your business model. So how do we do it? We have the business vision and the business model considered by the business analyst that if he or she does the job properly, will generate all those analysis documents. That we'll talk about those documents a bit later. But based upon those documents, then whoever is able to put software together will know what the goal is, will know what is important, will be aware of the business rules, the business policies, the business concept, the concept relationships. Those are the things what we call here the IT experts need to know in order to build the software that will support the operations of the business model. But we do have difficulties, we do have challenges. Now, some people might say, well, challenges, no, why? Why do we have challenges in software engineering? Because, software applications are easy to use, right? And they are powerful, they're flexible, they're intuitive. They never make major mistakes, all right? And I see all of you react, so you can easily change things around in all the software, and new releases come just on time, when you need them. They offer everything you need, okay? All right. Yes, there are challenges. Let me tell you about a few things we have seen on the field. These things are for real. We are being told, for instance, we don't really know who to bill for that water account. Well, the result, $5.3 million lost a year in a water department in Michigan. That was in March 2002. From a bank in Chicago. If a customer owns 2 checking accounts with us, then his personal info will appear twice in his savings account. How's that? Back in 1997. Another example. That insurance company was so excited they could offer insurance policies in southern Florida. In Florida in general, I should say. It took them 3 months. Their team worked around the clock almost for 3 months. 45 developers, almost 7 days a week. But that was Florida. This is United States. We still have what? 49 states to go, right? Now, why is our lead engineer now playing with that rope on the ceiling? What is going on? So that was, again, a large insurance company in Chicago. That's one of the challenges we have seen in the field. Some people tell us, well, in fact, that engine company, diesel engine company told us that they had, their IT system was working so poorly and would not support their operations at all, that they decided to get rid of 99% of their IT staff from the whole world. That's the most extreme we have ever heard. It does happen that an IT system would not work, would not deliver the services. That was in October 1998. So having heard those interesting stories, let's focus now on success and think for a minute. What does it take to have a successful software development? Well, the first thing is the subject matter, as we have talked about. We call that the problem domain. That is, of course, known by the subject matter experts, is known by the stakeholders. Those people have the knowledge. We need to describe it in a way that is true, that is precise, that is comprehensive. That's all we need. True, precise, and comprehensive knowledge of the subject matter. And this will take care of 1/3 of the equation. Next third, what we call here the internal architecture. How the software is built. The developers are doing that. What do they need? They need to have simple code. Code that is also flexible, that is powerful, that is well organized. A code you can that is proper, that is correct. Okay? And when we said flexible, you can change things around, or you can offer multiple options easily. That's what the internal architecture is about. If the internal architecture follows those characteristics, then you have taken care of the second third of your equation. The second third of your equation. So, the last one, as you might imagine, is the presentation to the end users. What qualities does it need to exhibit? It has to be intuitive. Imagine you sit in front of a software, and it's really not intuitive. It goes against intuition. That would be very bad. It does happen. The software has to be collaborating with you, as opposed to slapping your hands. Sorry, we're not supposed to go into systems preferences. Now that you have done that, your entire work is dead. You have to do it again. That would be a system that does not collaborate with you. Your system has to be powerful. As an end user, you want to make a few clicks and enter a few numbers maybe, and then here it is, you get your result. Above all, surely it has to be simple. Complicated is no fun for anyone. We approach the software in order to accomplish something. If it is complicated, it slows us down. And that is the third of your equation, the last third of your equation. So if you have that, then your software is well balanced. Balanced between the concepts, the requirements, the way it is built in a flexible, in a powerful, organized way, and the way it is presented to the end user in a simple, intuitive, collaborative way. That is software. This is successful software development. It's only those three aspects. Now, let's focus on this area on the left-hand side, and that really is about analysis. So that's what we call business analysis for software development. Because most of the time people write software to support their business operations, I would like to mention though that it could be an engineering problem domain, it can be a medical problem domain, it can be anything. And that is analysis. So what we would like to do in our next presentation is go over analysis, the way to succeed in analysis. We will look at the tools and we will look at the way to use those tools.